So today we're going to look at some sea level indicators that you can find along the coast of Moreton Bay at Cleveland, which is to the east of the Brisbane area. So here's an aerial view of the coastline here. And you can see the wide, broad foreshore coming away from the road there. Now there's been a lot of development in the area, but the foreshore itself is relatively undisturbed. And there are seagrass beds out towards the bay, but as we get in towards the road here, we find that the foreshore consists of this very blocky rubble material. So close up, this is what the foreshore looks like. It's made of these large blocks of material sitting together with one another. And if we look closely, we can determine what these are made out of. So looking closely, we can see what looks like some fairly obvious corallites. Now clearly they're not alive anymore, but the entire foreshore here appears to be made of these corals. So that's what's forming the substrate upon which we're standing here. Now, one of the things that's very useful about corals is that you can tell a lot by looking at the shape of them. So, for example, we have here some branching coral, some fragments of branching coral that are in the rubble. Now, the majority of the corals are these massive and very robust forms that we see typically in shallow water because they're robust enough to resist waves. And also you can see that they're interlocking to a greater or lesser extent. So they're growing into one another. The corals appear to form a surface. So they're forming a relatively flat surface that you can see across the top of the massive corals here. And this tells us that this is a mature reef that has grown up to sea level at some point in the past. So it's giving us an indication of what sea level was. And something else to notice is that these corals are what we call subaerially exposed. They're exposed above sea level. Now, corals can't grow typically above sea level, so they're telling us that sea level was higher in the past. And we know, in fact, that these corals are about 1 metre above the mean low sea level, which is the highest point that corals will grow to at the present day. Now, we can take samples of these corals and we can take them to the lab and we can dissolve them in acids. We can start to do some fancy chemistry with them, and then we can analyse them in an instrument called a mass spectrometer. And the mass spectrometer is capable of looking at isotopes of different elements like uranium and thorium in the coral, and that gives us a very precise age of the coral. So now we can take the relative height of the corals above the current sea level and their age, and we can plot those all up, as you can see here, and that allows us to work out sea level trajectories over the last, in this case, 7,000 years. So this is a really important data set, and it shows us how sea levels have changed in the past in any given area, and that's going to allow us to make projections about how sea level will change in that area in the future.